Yeah, okay. Welcome, class. Glad to have you make your presentations in advanced statistics. I will. I'm calling in from Paris, in France. Attending UNESCO meeting here, but as you are aware, my being in and out of LASU does not in any way stop our work. I quite a lot of you are here, but a number not here on account of whatever challenge that they have. So today we are looking at analysis of variance, analysis of covariance, which we learn in class. This is just the seminar part of it. So as we agreed, we are going to have John Sefamuide make his presentation, and then we'll ask questions, and then Stephen Akitolure will make his own presentation, and then we'll ask questions, and that will be it for today. Again, welcome. So, Francis, where are you calling from? Where are you attending the class from?
Yeah, I am at Shibri in Lagos.
Yeah, okay, that's fine. Stephen Akitolure, where's your location now?
Agbara,
Agbara,
Lagos,
that's good.
Nigeria.
Joseph Amuide, where's your location?
Anthony, Lagos.
Anthony, Omoraka Faith, I'm sorry. Where's the location?
I'm coming from AJ City, Lagos, sir.
Which city?
Ajegule City, sir.
Yeah, that's good. Yeah, that's good. That's good. That's good. So, Samuel, what about you?
I'm calling from Badag.
Badagry, Lagos. That's nice. So let's roll. Let's get on to Samuel Famuide. Famuide, are you set?
Yes, sir.
Okay, fine. So let's take your PowerPoint slide and we'll see how it goes. Let's see now. So, Famuide, you have the floor. Go ahead.
Good evening, class.
Yes.
Good evening, sir.
Good evening. Good evening, yeah, Dr. Pamuide. We're starting with ANOVA, analysis of variance, and ANCOVA. So with this slide, let's go to slide 3. Introduction. Why not use t-test repeatedly? The t-test, which is based on the standard error of the difference.
Sorry, Famuide, that's not how to do it. You are not talking to primary school pupils. You are not going to be reading your slides, for heaven's sake. I mean, is it your first presentation since you started attending school? Is it your first PowerPoint presentation? Definitely not. So, but go on, go on, go on. Learn to present without reading through the. You just highlight the main points. That's why it's PowerPoint. Go ahead.
All right. Why not use t-test repeatedly? The question is asked so that each and every one of us will be able to look at it that, okay, why ANOVA? Why do I want to use ANOVA? And the reason why we want to use ANOVA is because if you use t-test, because ordinarily people would have thought of, okay, let me go ahead and use t-test. T-test, which will only do test differences between two means. And when you do that, it's going to give severe inflation of the type 1 error. And this is not recommended. So let's go to slide 4.
Okay.
And the reason why we use ANOVA. Are we there, slide 4?
Yes.
Yeah, we're there. ANOVA is a method for testing the hypothesis that there is no difference between two or more population means. Often used for testing the hypothesis that there is no difference between the number of treatments. That is when we use it. And that error that we said that is going to come up when we use t-test repeatedly, ANOVA is going to take care of that. That is on point 3. That ANOVA is used to test for differences among several means without increasing type 1 error. Type of ANOVA, slide 5. One-way ANOVA, then two-way or factorial ANOVA. On slide 6, we look at the assumptions for using ANOVA. Normality, homogeneity, or variance, popularly called homoascendancy.
homoskedasticity. Anyway, don't let it break your jaw. Just keep going. Just stick
Yes.
with homogeneity of variance. Yes.
Okay, sir. And then independency.
Is
And
it
one thing we have to
independency or independence?
independence, sorry, independence. And one thing we have to note about ANOVA is this, that it's so robust, so it's kind of moderate violation of its own assumption. And we said that by saying that the probability values, p-values computed in an ANOVA are sufficiently accurate even if the assumptions are violated.
Yeah, sorry I'm interrupting you. Now that P must be lowercase p, not capital P.
Yes.
Please make a note of that. Yes, go ahead.
So let's go to slide 10.
Yeah, you've dealt with all of this. You see, the idea is not to, in this presentation, the assumptions you mentioned them on that one slide. So don't go ahead and waste so much time on all of this. What we want to do is the mathematical model, how it is used, when it is used, and when you get results of ANOVA, how do you interpret it for the purpose of your study? So why don't you go just skip these next two slides?
Okay. I said we should move over to slide 10.
Okay, which is the slide on what?
Basic framework of ANOVA.
Very good.
And
Yes.
the basic framework of it is that for you to do ANOVA, we have to look at it from the fact that it affects one or more qualitative variable on a quantitative outcome variable. Qualitative variables are referred to as factors. Characteristics that differentiate factors are referred to as levels. So let's move to slide 12. That is where we have the one-way ANOVA mathematical model.
Is there a mathematical model on this slide? No.
Yij is equal to mean plus.
Okay, that's the next slide. Okay, go ahead. Yeah,
Slide 12, sir.
that's slide 12. Yes, go ahead. Yes.
Plus the error. Then we try to explain what that is, that Yij represents the j observation on the height treatment, and so Y23 represents the third observation using level 2 of the factor. The mean is the common effect for the whole experiment, while the Ti represent the height treatment effect, and Eij, which is the error, represent the random error present in the jth observation on the height treatment.
You have 2 more minutes.
Hello, sir.
Yes, I say you have 2 more minutes.
All right, sir. So let's go to when to use one-way ANOVA. Like we said, that one-way ANOVA analysis of variance is used to determine whether there are many statistical significant differences between the means of 3 or more independent unrelated groups. And then we talked about factorial ANOVA, which is the other part, and there is a table that shows the difference between the one-way ANOVA and the factorial ANOVA.
Yeah, be taking us through which slide number. What are you, so that you can? I'm advancing with you.
16.
Yeah, okay. Go ahead.
Slide number 16.
Okay.
So a table differentiating the one-way ANOVA and then the factorial ANOVA. The independent variable for a one-way ANOVA, it is just 1. Why that of factorial is from 2 upward. And from there, because of time, let's go to slide 24. Example of a study where ANOVA is used.
Okay, now let's just do it like this. You have an analysis of covariance, which has to do with your inserting covariance into the equation, and then use of ANCOVA. You've indicated where those experimental designs, those designs where it can be used, the assumptions of ANCOVA, and example of study where ANOVA is used. So you missed out that huge chunk of it. You just have next time just gallop through the slides. Just tell us that this slide is about this and all of that. So we're on your last minute examples of a study where ANOVA is used. Yes.
And the purpose of the study is to, okay, sorry, slide 25.
Yes.
A recent observation showed that some federal and state universities specifically prefer to admit candidates with 5 ordinary level credit passes, including mathematics and English, at a sitting WAEC or NECO SSA, rather than those candidates who combine the maximum of 2 WAEC or NECO SSA results to make up the 5 ordinary level credit passes requirement. So this study, what we want to do is to consider the academic performance of students that are using 2 sitting, or those people that are using 1 sitting, who performs better. Should we encourage that people should use 1 sitting, or we should encourage that people can still, other universities can also still take people with 2 sitting?
Yeah, you have one. Your time is over. I'll give you 1 more minute to just wind up.
Okay. On slide 26, we see the research questions. On slide 27, we have the research hypothesis. There is no significant difference between the academic performance of students admitted with minimum of 5 O-level credit passes to WAEC/NECO SSC result at a sitting, and students who combine maximum of 2 WAEC. And the findings, okay, on slide 28, we have descriptive analysis of demographic profile of the students. Slide 29, faculty of education, the representation of it. On slide 30, we have analysis of research question and hypothesis. And we have the table on slide 31, slide 32, analysis of research question and hypothesis. Analysis of research question and then the summary of the findings from the study. It was found that the academic performance of students in faculty of education is not subject to whether they were admitted with minimum of 5 O-level credit pass in WAEC. And all these findings that we got were done by using SPSS, and the model of the research work is factorial 2 to 3 factorial ANOVA.
Okay, last minute now. Yes.
Discussion.
Yes, go ahead. Take the last minute.
Go ahead, sir.
Go ahead now. You have 1 minute. Yes. Thank you, Madam Faith, for prompting him. Yes.
Conclusion. Consequently, I submit that the WAEC NECO SSC as that's slide 39, sorry,
Yes.
as a cognitive entry characteristic does not have a significant difference on the academic performance of students admitted with minimum of 5 O-level credit passes in WAEC result at a sitting, and students who combine maximum of 2 WAEC NECO SSC results to complete 5 O-level.
Okay, thank you. Thank you. Can you applaud him? All right. So let's take comments and questions. Madam Faith, what are your questions for him?
I will commend him for being the first person. It's not easy to be a pace setter, but
Yeah.
I would rather say that he kind of rushed it. I really did not get much. So I'm still trying to go through the slide myself, but I really did not get much. That's all, sir.
Okay, that's fine. Samuel.
Aside the fact that PowerPoint slide is not too nice, I would follow fit to say that I joined because a lot of people won't make few mistakes that just say okay, and also pay the cost and waiting. And however, sir, on assumptions of using ANOVA, I read up something that I wish to really add to the class because when I was trying to understand it properly, I read it.
Can you be brief? Can you be brief, please, Samuel? When you are presenting your own, you can expand on that
Right.
because we wasted quite a lot of time in taking it off, and my other class is starting very shortly. So yeah, just go straight to your point.
I just want to add that you also call your parents.
Okay, that's fine. Stephen, yes, Shino.
Good
Okay,
evening, Prof.
we can't hear you now. So let's
Charlie,
no
good
no
evening,
no.
Prof. Dr. Fa-
Go ahead. Go ahead, Shino. You are presenting next. So go ahead and ask your question.
just want to applaud Dr. Fa. Okay, sir. So I
Yeah.
just want to appreciate the job he has done. Like Faith said, being a pace setter, I believe we can improve on what we have here. Thank you, sir.
Yeah, that's very fine. Now, Johnson, you know what the strengths of your presentation are, and you know what the weaknesses are. So for the next set of presentations, try to improve on your slides. Apparently, you did not. We're not in class. You didn't join us early enough when we're looking at uh, analysis of variance, analysis of covariance, which are statistics for undergraduates rather than for postgraduates. Yeah, recall that I brought this in to enable me build on multiple on MANOVA, multiple analysis of covariance and multiple analysis of variance, because I needed to have a good foundation. There are quite a few things that uh, are not correct with the analysis that you use for that kind of study, but we can be looking at that outside class. So once again, well done. Now let's take on Shina's
Thank you, sir.
presentation. Let's try to get your slides, and then we can begin to take your. We can then you can then present. 1 minute, please. Yeah. So this is your slide, Shino. So Shino, you have the floor. Please go on.
Good evening, Prof. Good evening, class.
Yes. Good evening.
I'm Stephen Urashina Akintolure. I'm going to present the topic ANOVA, analysis of variance, ANOVA, and analysis of covariance, ANCOVA. Basically, we want to look at what analysis of variance is and what analysis of covariance is. Analysis of variance.
Do you want us to go to another slide? Shino, look, listen. That's why we loaded your slide. Do you want us to go to slide 2 or slide 3 or just stay on the title slide?
Sorry, sir. Slide 3 now.
Slide 3, yes, okay.
Yes, sir.
Go ahead.
Analysis of variance is a statistical tool, and what it does is just to compare means. Compare means between mostly two groups on one dependent variable. Like Professor Peter Okebukola told us severally in class, for example, you want to look at performance or achievement of group of students being taught using different methods. In such cases, analysis of variance will be to be used.
Yes, you're correct.
Very quickly to slide 4. Slide 4 there is telling us about the first man, the man who was able to bring the term variance, and that is Professor R. Fisher. He was the first man to use the term variance, and he did a lot of work that made us today to understand the usefulness of analysis of variance in the practical field of education and social science.
Good.
Very quickly, we'll go to slide 5 to talk about the purpose of using ANOVA. ANOVA is just a statistical tool that we basically use to compare mean. When we begin to look at the assumptions, we'll be talking about homogeneity, analysis of variance, compare mean between groups. And what it's interested in is you want to test if there is a statistically significant difference among those mean from each other. So the purpose mainly why we use ANOVA is to test the difference in the statistical difference of the data we have or distribution at most times. We'll go to slide 7. Slide 7 there is showing you the mathematical model for ANOVA and the reference from where it was gotten. That means we're saying that there is a statistical model that back up what we do when we talk about analysis of variance. That means we have a mathematical model for it. I go to slide 8. When to use ANOVA.
Yes.
When to use ANOVA. Professor Peter Okebukola have said it severally that you might have situations where you can randomly select, and there are situations where you are not given the opportunity. So what would I say here about analysis of variance is that when you have groups that are randomly selected, or they are now split into smaller groups and they are completing different tasks, then you can make use of ANOVA. Or rather, when the groups are split into groups based on their attributes, we have different attributes that we could use to measure achievement or performance. So these are cases when ANOVA could be used. Quickly to start, slide 9. On slide 9, you have an ANOVA table. The table explains clearly what the table of ANOVA looks like. You see on the first column, you have source of variation. The next, you have degree of freedom. The next one, you have square, sum of square. Next, mean of square. And the F, which is the Fisher table. You have between and within. We want to look at the variation between and within. You have the degree of freedom as K minus 1 between and N minus K. K minus 1 there means that you are looking at the number of cases. If the cases are 5 minus 1, if the cases are 3 minus 1, then within you have that is the total number of observations minus K, which is the number of cases you have. It takes you further to calculate the sum of square, the mean of square, and finally the Fisher table, which we say F is always MS divided by MS within. That is the mean of score between divided by mean of score within. Will always give us our F value. Very quickly, we move over to slide 10. Slide 10 now is talking about analysis of covariance. You remember we talked about us looking at the mix of two or three groups on a dependent variable. What analysis of covariance do is that analysis of covariance want to test if there is an extraneous variable, the covariance. That means there's a factor that could influence, that could determine, that could affect the performance of students or in any situation. So we always want to test any extraneous variable or covariate. It is advisable we use the analysis of covariance. Very quickly here on slide 11, we have the purpose of using ANCOVA. And the purpose here, like you see that we've talked about covariate, the purpose is just mainly to test the interaction effect of categorical variables on a continuous dependent variable. We move to slide 12. I'm looking at assumptions for ANCOVA. You have the first one, independent. That means when you are observing, observation should be dependent. What this is saying in effect is that you should participate in not more than one group. You cannot put one person in where you replace the person in group C. The most observation should be independent. The second one is variable are covariant. That means the dependent variable and covariant should be continuous variable. That means they measure at interval ratio in interval scale. And the last one is that the relation.
You have 2 minutes more, Shino.
The relation is linear from group to group. Very quickly to 13. Like I didn't tell us when to use ANCOVA. It is used when you want to test interaction between groups. Like 14, mathematical model, you've seen it there, you've seen the reference, y equals uj, and the rest of it. Then, what we are now saying, that I will explain finally, is that we look at what makes ANOVA different from ANCOVA. ANCOVA is when you are considering an extraneous variable on the data on the group you have. But you use ANOVA when you just want to test the mean variable. That means, for example, if you ask a question, is there any statistically significant difference in the performance of SS2 physics students taught using observation method, lecture method, and display method? If you look at all the methods, you are just testing it on performance. You use ANOVA. But in the situation whereby you have an extraneous variable that's a covariate, you make use of ANCOVA. Thank you. God bless you for listening.
Thank you very much, Shino. You can see the class is applauding you, and well done. Yeah, it shows very clearly that you were part of the early class. Those that just jumped in towards the end, Faith and Johnson, is showing that they didn't have that initial scaffolding that we put to bring you up to speed. So very well done. So let's take some quick questions for him. I've overrun my time for the next class. So Samuel, ask your question straight. Don't go rambling and giving us all manner of
I don't
stories.
have
Okay, that's fine. Yeah, Madam Faith.
Well, when he discussed about ANOVA, he was supposed to talk more about the assumptions, which he skipped on page on slide 7. I think that is also very important to this presentation. And your references, please next time bring them together at the end of your presentation. Thank you.
All right. Johnson, Famuide.
I want to applaud him for a good presentation, sir.
Okay.
And I've learned greatly from how he presented.
Exactly. That's what I love to hear.
Thanks.
Madam Mary cannot join us. She's here, but we cannot hear her. I think she has to do something about her audio. Francis, you heard. So what's up, Francis?
Sir, yeah, in the presentation, he didn't conclude. Immediately after they talked about the statistical significance, or it just ended up without giving any conclusion.
Yeah, I think he did. He did. He did.
He did. Maybe you didn't
He
hear
did.
him,
Maybe
sir.
you didn't hear him. Yeah, exactly. He didn't hear him. Yeah, so he did, and let me put on my video now. I just forgot to do that. Yeah, he did. Yeah, okay. Yeah, he did. He presented his conclusion. What I think he didn't mention, if you all will notice, is that he didn't talk about the fact that in education, when you cannot assign to random groups, you use analysis of covariance, and then you use the pretest of any of the dependent variables you're interested in as covariate. So we need to underline that you use analysis of covariance during when you have interclasses. So that would be it. I'd like to thank you all. We have done very well today.
Thank you, sir.
Yeah, so please for tomorrow's class, we're not repeating any ANOVA and ANCOVA. We're going to the next set of statistic. So who is presenting tomorrow among those of you that are here?
Samuel, sir.
Samuel, okay, you are presenting tomorrow. Francis, you are presenting tomorrow. Please learn what you should do. Send your files and then learn where the files are located so that you load them. And then, Francis, as you've noticed, Samuel, as you have noticed, we're walking people through slide by slide. And Mary, try to fix your audio because we cannot hear you. And so that will be it. See you tomorrow, same time. And God bless you. But did you get the information that we're going to have an on-site class on Saturday? I thought I
Yes,
sent
sir.
by text message. Okay, that's fine. Okay. So good night to you all, and have some nice evening. Bye bye.
Bye bye, sir. Thank you.
Thank you. Bye bye. Okay.